So we said user-centric charging solution. I'm Guido Sacchetto from European Commission, DG Research Innovation. As you might know, I'm in charge of one of the partnership under Horizon Europe, which is the 2.0 partnership. And this is interesting also because it will be one of the main points of research and innovation of the partnership as well, because the 2.0 partnership, as you might know, takes into consideration systemic approach, so changing and watching at the vehicle, the recharging infrastructure, and the link to the grid. In this session, we have the possibility to analyze and to understand what are some projects, 3 quite big projects, with also interesting and important budgets. What are they proposing for this area? What are the main results and the area of investigation they're analyzing? Why charging? Well, charging, as we know, maybe just to put a little bit of set the scene, is one of the main challenges for the coming years for the electrification of the transport. And it is clear that we need to have in the future something that is supposed to be user-friendly, used by the citizens, with the wide standardization of all the recharging modes, but also to provide a better experience to all the travelers, so to really be used by all the citizens and in the different ways that it can be used, not only. And this is where we enter into the main point of the 2 topics that I will present, linked to the smart charging, so the vehicle to grid or the vehicle to everything, because we know that the vehicle, the electric vehicles, can provide a good part of the charging solution, balancing the needs of the grid. And this is why the 3 projects presented today, INCIT-EV, EV for EU, and Scale, coming from 2 different topics under Horizon 2021 and the other 2 under Horizon Europe. One on user-centric charging infrastructure, starting in 2019, INCIT-EV, and we have Miguel, who will present it in a couple of minutes. And the other 2 for the topic under Horizon Europe on system approach to achieve optimized smart EV charging and vehicle-to-grid flexibility in mass deployment condition, because we want to understand when we'll have a mass deployment condition of electric vehicles, what will be the impact on the grid and how this will help benefiting the grid. So maybe just a few seconds just to say what are the rules. It will be 15 minutes presentation from all the speakers. Then we will ask for immediate question or clarification in the room if there is any points that need to be explained a little bit more. But please keep any question for the question and answer session at the end. As we said, we're quite lucky. We just have 3 projects, so we'll have all the time to present and to discuss the result at the end. And it will be, of course, moderated by Christof. I think you know Christof. Christof Schernus is Vice President of FEV, Research Innovation at FEV Europe, and is also current President of EARPA, the European Automotive Research Partner Association. Together we'll be doing this session. I will present, introducing the speaker, and then, of course, together, and basically Christof will take care of the question and answer session. We have 4 speakers on the table, but we only have 3 projects. So we have Miguel, who will be presenting INCIT-EV, Hugo and Mattei will be presenting EV for EU, and Bart for Scale project. We'll start with Miguel Zarzuela. I can give you the power, and you can, as you wish, you can sit there, present, or stand at the table. And I can only say, well, Miguel Zarzuela is the European Project Coordinator at Circe Technology Center in Zaragoza, Spain. He's an industrial engineer specialized in energy, and innovation projects. He's coordinating some flagship projects on electric mobility, decarbonization, and net zero cities. I'll leave you the floor for now, let's say 15 minutes, and then I'll give you a call when the time is almost done. Thank you.
Excellent, Guido. It's a pleasure to be here. I was here 2 years ago after the pandemic in the same season. So 2 additional years have passed. So as we said in the morning, I believe that we are at this point ready to forward to you all the outcomes and the results of the project. Just quickly to introduce you INCIT-EV. This is an EU project of about 19 million, of which 15 are funded by European Commission. is based in 7 use cases across Europe, and the main objective is to develop a set of innovative charging technologies in order to foster electric mobility into the final users. I will go into the details later, but just you to know that the project will end in June, so we are about to release all the final information, and we are on the final implementation phase of all the demonstrators. Just as an aperitif of what we'll see, we are very happy that we have started the demonstrator of inductive charging in Paris. This one was developed by BDCom, one of the partners of the project, and will be ready to welcome you in June for the demonstration on the city of Paris, in which this use case will take place. Just you to know, we have a very large consortium of 33 partners in which municipalities involved in the neutral climate cities mission are involved, also RTDs, universities, large companies. And together we are working mainly on smart charging, B2X, and inductive charging, and its associated business models. So let me start from the beginning of what we have done in INCIT-EV. We started working on what are the preferences and expectations of the BE users as a user-centric project. Once we know that, we develop the technologies, mainly bidirectional charging and inductive charging in the use cases. I won't have today the time to present all the results, but just you to mention that we have also developed a decision support system for mobility planners. This decision support system tool allows a city planner with the given information of electric vehicles on the city and the expected sales in the coming years to plan the charging infrastructure in terms of low, medium, and high power charging points in order to be installed and meet the demand of the future demand of that city. Concerning inductive charging, we've made a huge effort of the partners collaborating in the project towards interoperability. We have developed a system in which 3 different ground systems are developed, but are interoperable between them with all the vehicles in the project. We have 4 vehicles in which they can charge in all the 3 demonstrators of inductive charging, which is one of the challenges of this technology in the coming years. Also concerning bidirectional chargers, we have developed technology for 3.3 chargers, for 25 B2G chargers, and also for 200 B2G ready chargers. We are working on the final information on the CAPEX, OPEX, and operation of all these business cases, which will be very relevant in order to assess the business, the attractiveness of these technologies in the coming years, and also for the transfer of this technology. Let me just recap what are the pains and gains that we obtained for the users. We had more interaction with more than 5,000 users via surveys and working groups. They, of course, what they want from an electric vehicle that will be, they want to be cheaper, that charges faster, and that runs longer. But if we need to have concrete bullet points, we need to offer them a seamless and reliable charging. This is key point. Fast and interoperable charging when traveling. Also, as you know, the vehicles charge about 80 to 90% of the time at home or at their offices, so low power, low cost, in which we need also to charge them at the right time, including smart charging algorithms and some price indication. And also they are eager to integrate them into smart grids, into photovoltaic systems, and to use them as a battery for their homes, but maybe in the future also for the grid. From the grid operators' point of view, it's an increasing demand of storage in the grid, and the assets of the electric vehicles that for final users, not professional ones, are parked maybe a 90% of their time life in a park slot. They will be very relevant for the energy transition, also for the use of this storage into the grid. They also would like to have not only energy, but also some ancillary services as frequency or voltage regulation on the charging points locations. Let me show you on the right side some information about one of the use cases. We had 250 public points managed by Total, in which algorithm of smart charging was implemented. Here you have some of the graphic of the power charging. Applying smart charging, we can reduce the peak demand at peak hours. If it is more aggressive, we can further move this power demand into the night, always that the user have all the night for charging. This is just an application on public point operators that with the dynamic pricing can also offer a saving for the user when applying this smart charging scheme. Another big point that I will discuss later, we have in this project also bidirectional charging on AC level and on DC level. But we are in this point, all the partners involved working on the recent standard of the ISO 15118-20, which have all the functionalities available with not only B2G, but other functionalities, but are still not fully available on the vehicles on the street. And still some of the tests are pending for achieving the full B2G capabilities of the demonstrators involved in the project. This is one of the demonstrators. This one has been installed in public street in Zaragoza. It was developed by FIRFE, and this is a 25 kilowatt B2G charger made of silicon carbide MOSFET technology. So the innovation here is the high frequency switching and the high efficiency of this new MOSFET technology. In this case, we have already developed B2G charge and discharge, even between vehicles. Here you have a picture when we were discharging a Nissan EV towards a Renault EV, the same that we are using for the inductive charging. Here we have achieved 95% of efficiency, and we are aiming a cost of about 0.25 euros per kilowatt, which is quite competitive with existing chargers that are not bidirectional. Let me move to the inductive chargers. This one is the most simple, is static or semi-static. This one is thought for a taxi queue in which a vehicle is stopping for a time and then it will be moved. It will move to the next station or to the next position in the queue. This charger uses partially the same technology of the previous charger, but in this case we have the inductive stage in which it is converted to alternative current and then transformed into DC current in the vehicle. So we have a coil in the ground and a coil in the vehicle and then a DC-DC on the vehicle. Here you can see the coil that has been installed is the one that is here on the commissioning. This coil is oil cool, so it allows to operate 24/7 to release the heat that is lost while charging. Here we're still on the final testing. At lab test, we are achieving about 90% of efficiency against a conductive charger. And in some misalignment or bad positioning of the vehicle, we can work in about 85% of the efficiency. This is the most simple one, and here we have the same approach, but in motion. Here we have 30 meters charging lane, in which each meter we have a coil in the ground and an inverter in the ground. So while the vehicle is moving, each of the coils are activating and deactivating, and we are transferring the energy in motion. We have different vehicles, Stellantis vehicle, a Renault vehicle, heavy duty, well, it's a Master, and a Renault Zoe, and three of them have the same power electronics on board and are totally interoperable between them. Here you have some of the videos of Betecom Lab where the misalignment, some of the control systems were tested. Again, here with a good alignment, we are reaching the same 90% of efficiency. And then we have a misalignment we have a tracking system in the vehicle that helps the driver to keep on the track to reduce the misalignment, and we can reduce the power. This is expected to have 30 kilowatts. If it is not very aligned, we maybe can have 25, 26 kilowatts instead of the expected 30. So it depends also on the misalignment. Here you have is a prototype development, but here you can see the power electronics on the trunk, where the electricity, the AC power is converted into the DC level required to be charged the vehicle. Here you have some other nice testing. This won't be the final location. This use case is going to be installed in one of the districts of the Paris city, so you will be able to see it on open street test. This is one of the evolution of this system, looking at reducing the cost. With the previous system, depending on the manufacturing process, but we can maybe say that it will cost between 6 and 10 million euros per kilometer. Here we are maybe dropping the cost by 5 to 7 times because we are using a larger coil. Instead of using a coil of 1 meter, we are using a coil of 10 meters. Therefore, we are only using one inverter per 10 meters, so it's 10 times less power electronics per segment. This is the simplified demonstrator that we are testing right now in Zaragoza, and this will be installed in the coming months in Versailles, in Paris, where 80 meters of this high speed that is expected to reach more than 100 kilometers per hour will be able to charge the vehicles on highway conditions. Here the goal is to fit up to 3 coils at the same time, so 90 kilowatts for the van that has 3 coils at the same time. Here, as said, the main or the pending challenge is interoperability, because at this power range there is still enough standards. So INCIT-EV is looking forward that the results of this project will pave standards for 85 kilohertz frequency switching operation, and also some misalignment operation in order to do not be always perfectly aligned in order to work in any of the conditions. In terms of conductive the bidirectional charging, as said at the beginning, we are pending of the full release by the automotive industry of the last ISO standard, -20 on the vehicles. There is some reluctancy of the automotive industry to B2G because it will increase the cycling and probably the aging of the batteries, even if it is take a very low power. But there is still some concern, or maybe once it will be open, we are seeing some limitations in the kilowatt hours or the hours that a vehicle will be able to work on B2G, so this will reduce the business model of this application. I'm sure that the project that we have in this session will take more and deep analysis of their younger projects, so they are facing a more advanced implementation of the V2X ecosystem. As said, since the beginning, we have been working with other projects, especially with the ones in the same CAL, but we are right now working also with the projects that we see in this session, and with others in which we have collaboration and synergies. Especially we are working on the policy recommendations at the end of the project to be aligned on using all the outcomes for all the projects. I will just briefly, in order to be in time, just mention about the long-term impact. Of course, we are aiming to have more electric vehicles on the road. In terms of the project, we are aiming to have cheaper power electronics in terms of chargers, including B2G, that are expected to be released in the market in the coming years. And also these chargers allow the DCOs and the TCOs to have improved grid quality and resilience. We have working, so some of the parameters of the grid can be operable by the chargers, so in terms of frequency regulation, voltage regulation, and of course smart charging will allow flexible demand from the demand side of the vehicles in order to adapt the generation and the demand hour by hour. so to allow further incrementation of a further use of renewable energies in the grid system. Of course, interoperability of all the solutions, inductive, conductive payment schemes will be key, enable that this technology will be released in an important percentage in the streets. So just to end, I will encourage you, if you want to learn more about the project and specifically the final deliverable, the final outcomes, to register at the newsletter. So you can do it on our website. And we are planning the final event with the live demonstrator of the Paris and the Versailles inductive charger. In June, 26th of June, we'll have some in-person attendance for stakeholders, but it will be open to the public, so everybody can be able to join it online. So that's all from my side, and I will be eager to hear your questions in the discussion round. Thank you very much.
Thanks a lot, Miguel. Also perfect timing. Any specific question for clarification right now? Then keep the long question, the discussion for the end. But anything that we need to clarify on the presentation? I have one really very specific question, Miguel, maybe just to understand better. So the test that you're doing in Paris is 80 meters, and you want to test it more than 90 kilometers per hour?
Yeah, exactly.
So it would be 1 second to second?
Yeah, the time, I mean, what is very complex is the transition between coils. So indeed, once we work on that, on two transition of the coils, that's enough.
So to have two transition at least, okay.
Yeah, exactly. So we have two demonstrators, one that will be on urban environment, so with 30 meters, 30 coils, and the other one will be in the outskirts, close to Versailles, and this one will be the one of 80 meters. It is just a matter of replicate the system and to add more meters, that at this stage we have enough to develop, to manufacture, to test, and to fine-tune all the system.
Okay, thanks a lot.
And I think there was a fence behind that straight. So you're sure that you managed to do the turn before you hit into it at the end of that lane? Okay.
Yeah, it was planned to have, this is a test track with also military tests are done. Yeah. But due to the military test, we were not allowed to be on the main track. So we are on a side track close to a wall, but we are able to reach that 100 kilometers per hour.
Stop the car, right? At the end, yes. Otherwise it's going to be difficult. Okay. Any special question? No? Thanks again then to Miguel. And we can move to our second project. As we said, we presented EV for EU. We have two speakers, Hugo Moraes from Technology University of Lisbon and Matej Zaj from University of Ljubljana. I think it will be Hugo starting to present, and then Matej will continue. Hugo is a senior researcher at, associate professor at University of Lisbon, but senior researcher is also at INCIT-EV, and is working a lot on smart grid methods and tools and on strategies for electric mobility integration power systems, so precisely what we're aiming for. Matej is a professor at the ICT department, University of Ljubljana, working on ICT and smart grid, with user-centered services, V2X, so vehicle to everything, and integration into the power grid. Good background, wonderful speakers. Please enjoy the next 15 minutes. Thanks.
Okay, thank you. Thank you very much for the invitation and for the opportunity to present some results that we are obtaining in the EV for You project. Only to mention, this project is not in the end, it's in the middle of the project. We don't have yet results of demonstrators, but I will present mainly the results that we are obtaining in technical work package. Regarding the consortium of the project, we are 16 partners, divided in 4 countries, Portugal, Greece, Denmark, and Slovenia. And we have 4 demonstrators, and as you can see here, we are more or less exactly in the middle of the project. The project started in June of 2022 and will end in November of 2025. And the budget is around 9 million euros. Here we have the structure of the project. In fact, the presentation is divided in 3 parts. One is the objectives, afterwards some results, and we will talk a little bit about the demonstrators. I will talk about this framework in the following slides, but before I will talk in the objectives that we have in the project. And one of the objectives is to identify business models for different stakeholders. Miguel already talked about the importance of these business models. And what we did in the project was divide between the business use cases and business models to go deep in the value that the smart charging and the vehicle to grid can bring for the different stakeholders. Afterwards, the project also have a lot of concerns about the persons, the users, and what are the needs that users have for the different services that we will provide. Of course, to have smart charging and vehicle to grid, and knowing that most of the time the vehicles are parked in our houses, in our buildings, in our companies, we need to define different strategies to charge the vehicles in each one of the infrastructures. And it's not looking inside the vehicles and the way how we charge the vehicles, it's also looking in the state of the buildings, in the production that we have, and also in services that we can provide to the grids. Afterwards, we have this method to support integration of the EVs in distribution grids. And this is one of the points that if you look in the partners that we have in the consortium, we have distribution system operators in all the demonstrators that we'll develop. And what we are proposing here is to test different services in each one of the demonstrators and realizing what are the advantages, for example, to have implicit demand response, explicit demand response, local markets, or simply do the activation of services directly by the DSOs or TSOs. We need to create mechanisms for service to adequate for virtual power plants and CPOs. And this is one important part because most of the services will not be directly activated by the markets or by the system operators. We need these stakeholders. The CPOs is a stakeholder that everyone knows and everyone considers, but in fact to participate in the markets, we also need virtual power plants and balancing service providers, etc. We need to design and understand systems and grid services more adequate for EVs. This means that we cannot use the services that are used for regular consumers to DVs, mainly because DVs have much more flexibility than the other loads that we have in the system. This means that we should model services, but we should also find the ways to model the EVs in the process used by the DSOs and by the virtual power plants. Of course, we need to create cost-effective solutions to promoting this massive adoption of EVs. And here, what we are discussing is what is really needed. If we need more chargers, or, for example, if we need more plugs. When we talk in flexibility, the question is, we need always the flexibility, or we need flexibility only in some periods, or we can reserve some energy for flexibility, or if the best is to reserve some power to provide this flexibility. Afterwards, we have the assessment of the trade of B2X in smart charging in different regulatory contexts. And now regarding the results of the project. Until now, all this is only a procedure, but we have 26 deliverables already submitted and approved. In the total, we'll have 61 in the end of the project. Now, looking in this framework, and this is what we propose to do, and as you can see, we are looking in different points in the integration or to try to develop this massive adoption of the mobility. First of all, we will try to look in the regulation and in the business models and policies that we have. And here, in the beginning of this meeting, we talk about regulation. And one important thing to mention is that most of the services that we are considering and testing in the project, we cannot do because regulation in different countries do not allow the services. And when I talk in these services, I talk, for example, we have some countries that don't allow the vehicle to grid. We have countries where we cannot coordinate vehicles with renewables. We have some challenges to charge vehicles in energy communities. And all of these, we can propose methods and we can show the advantages, but afterwards we need to do some work with regulators, with the municipalities, with governments to allow these services. Here in the picture is a case in Greece where we are comparing this coordination between vehicles and renewables, considering the smart charging and considering the use of vehicle to grid. Afterwards, as I mentioned, we divided the business models in business use cases and business models. And why is this business use cases? Is when I need to activate one services like frequency regulation or voltage control, in fact, it's not only activate service. We need to understand who will start service, who needs the service. And in this case, if we talk in voltage regulation, in most of the times are the DSOs, and we need to think what are the changes that we need to do in the control center of the DSO to activate this service, what are the information that should be sent and for who should be sent, and what is the chain of activation of these services until the electrical vehicle. And this is what we call a business use case, is understanding what are the needs in terms of information exchange and who are participating in service. And afterwards, the business model is considering this case of, for example, voltage control, who will take advantage and who will profit and what is the value that this service will bring for each one of the stakeholders that are involved. In this case, we identified 7, 4 at system level, 4 at grid level and 3 at system level, and we try to identify both all the sequence of the activation of the services and afterwards the value that can bring for each one of the stakeholders. Afterwards, of course, we are looking also in the technologies, and here we have 2 main developments. One is to provide a charging station compliant with ISO 15118/20, but as Miguel mentioned, we are facing a lot of challenges because the standard is not completely full available, and we are having some delays. And the other solution is a solution to be used in the buildings, mainly to share the charging facilities or charging power between different places inside these buildings. And the goal here is to reduce the costs for the users and for the charging of the vehicles. Okay, afterwards we are looking in the users, user engagement, and we are conducting surveys as usual, but we are also promoting some workshops with different stakeholders. We are doing a kind of safaris to understand what are the experience of the users regarding the mobility, and we already did workshops in different countries, and we will continue doing the demonstration phases to learn what are the challenges of these users and how the users think about services that we are proposing. And afterwards, we have a lot of efforts to develop different strategies to integrate the vehicles in the different infrastructures. We are looking at houses and buildings that are typical applications that we can already find in the market. What are different that we are developing is that we are considering also the interactions between the houses and buildings with the grid services, and we are incorporating, for example, in one of the demonstrators, the wind curtailment, in another one, the participation in the markets, etc. Afterwards, we are looking in the energy communities and and in parking lots. And in parking lots, we are testing methodologies without a centralized management. This means that each charging station should be autonomous to take their decision according what are the parameters that he saw in the grid. When we talk in companies, we are doing a deep analysis because in the companies we have different types of users with different types of needs, meaning the fleets, the employees, the clients, the visitors, the third-party entities that work in the companies. And what we are developing is a method that considers different priorities for all of these type of users. We are creating here, and this is something that is already available, one open platform allowing the management of electrical mobility. This platform is mainly to be used by CPOs, but we can integrate any algorithm that we want, and will be available for the use of everyone. We have a lot of effort also in the integration in power systems and electricity markets. Here we are showing one example of how can we consider the flexibility of vehicles in the planning of grids. And we identified two different scenarios. One is when we don't have a lot of competition. What we can see this moment is what we have, and what can be in the future if we have a lot of competition, and we should include the vehicles in the trade-off of the grids. Only one important thing that this method, the option one, is nowadays being used by the Portuguese DSO to avoid investments in the grid, to replace this investment to flexibility that are posing in the market. And part of the methodologies that we use here, developed here for model the electrical vehicles, are being used nowadays in the Portuguese DSO. Regarding the markets, in fact, we will not develop a demonstrator, but will be a field test where we will change in Slovenia the control center of the DSO to include flexibility, the activation of flexibility. We'll profit of a platform that has been developed in the OneNet project to include the mobility services, and the virtual power plant will be a real virtual power plant that will pose flexibility of the vehicles in real markets operated by the TSO or operated by in local market by the DSO. And here is something that we still are developing for the second part of the project, namely this simulation platform considering the city information and some decision support tools for policymakers.
Hello, thank you for the opportunity to continue with a few additional minutes. My task is to quickly not present, but just to highlight the 4 demonstrators where all this work that we are currently doing will be tested. As Hugo was explaining, all the algorithms, all the methods, also the technologies that are developed, also the understanding of the users, policies and so on, will be tested in the 4 demonstrators. We started with use cases, as explained earlier. From use cases, we developed business models, and from business models, we developed business use cases. And those are the foundation for the 4 pilots. One will be on Azores in Portugal. I will try just to maybe highlight 1 or 2 things for each. As we are discussing in this project, the main objective is vehicle to V2X flexibility. We try to identify it, we try to take advantage of it. And in this demonstrator, they will be testing vehicle to building, bidirectional exchange, smart charging, vehicle to vehicle, vehicle to home. So there will be different parts of the island implementing this demonstrator. What are the challenges? Of course, the charging equipment, still under development. Another one, as Hugo mentioned, is regulatory frameworks, and also understanding how users are engaged. We are broadly following 2 paths. One is that users will be using an app and sort of being in a sort of interaction during this process. And another, in a Slovenian demonstrator, is where user will initially uh, agree for these services, but later on will not be part of this, let's say, interaction. The second one demonstrator is in Slovenia. It's in Krško. It's an office building with a car park, with a business car park, which is also open to public. As Hugo mentioned, the main focus here is to aggregate this with a virtual power plant and to offer the flexibility on local and national markets with the platform which is used or implemented from previous project, in this case, OneNet project. What are the challenges? Again, from, let's say, the entire demonstrator, the charging stations are now, let's say, a weak link. They are under development because of the changing the standard. Some other issues, of course, setting up a local market, which is underway, and we expect that will be done during the demonstrator. The third one is in Greece. It's surrounding of Athens. Hugo mentioned that open platform for CPOs is developed. This will be part of this demonstration where CPOs will be aggregating the flexibilities and, of course, offering to DSOs. Challenges, some coordination, which also is now being resolved. And the last demonstrator is in Denmark. There are actually two. One is on island Bornholm, where energy communities could be the, let's say, the first keyword. And the second one is DTU campus in Denmark, close to Copenhagen, where the technology will also be tested. As we said, a small portion of the project is also development of coordinating of charging stations, and this will be part of this demonstrator. What are the challenges? Autonomous management, how much autonomous, what is the coordination between EVs and renewables, and so on. So this is very, very briefly on the four demonstrators. I would like to point to our website where each demonstrator is described in the deliverables and, of course, questions to our discussion which will follow. Thank you very much.
Thanks a lot. Thanks a lot, Hugo. Thanks a lot, Matej. Do you have any specific question or request for clarification? Just give a second just to understand also for this project. As you know, we see where are the points that will need to be discussed and the main challenges. This is why we're also investigating after demonstration of pilots, because there are many stakeholders and we need to strike the right balance between the use cases and the business cases as well to see something feasible and viable for the future. No request for clarification, then we can continue maybe now with the second project, with the third project. Still in the same topic, so Horizon Europe started recently, let's say, so less than 2 years, and the next speaker will be Bart de Brey. He works and is in the executive board of ELAD Netherlands, as you might know, a collaboration in the field of smart charging infrastructure, and he is really be presenting, well, the project is scale. It's really on the long-term effect of electric mobility. This is his field of expertise, but in particular on sustainable business cases, which is what we are looking for with this specific topic and the projects. But the floor is yours. Thank you.
Yeah, thank you. SCALE is an abbreviation of Smart Charging Alignment Europe, but actually it's on bidirectional charging, but that doesn't make a nice abbreviation. As in the other projects, it's about preparing for mass market and user-centric. So that was what we submitted almost 2-3 years ago, and we just did our midterm report, so we're halfway. Consortium exists of a lot of different countries. I'll give an overview on that, but also a lot of different value streams. As you can see, some hardware providers. ABB is a charge point manufacturer. But what makes us a bit unique is that we also have the car manufacturers on board. Renault, Polestar, Hyundai, Sono was there at the start, and VDL is a truck manufacturer. They produce trucks and buses. But also the service providers, grid operators and research institutes, but also some municipalities, because you also need them. And lastly, TSO and DSO, as mentioned in the previous project, that also has to be aligned. As mentioned, different regions, a little bit of the Nordics, Oslo and Gothenburg, and of course you know the Polestar factory is over there. In France, we collaborate with Renault, and we have a huge test site in Toulouse, the Munich area in the Netherlands, but also Hungary, which gives also some other insights. User-centric, so where did we start is with the consumers. Also here is my colleague Mariska, and not one, but already two consumer surveys. Really one at the start, one halftime. We did it in September this year. A lot of people responding, over 40 different countries. We had reactions and over 3,000 filled in surveys. And the last survey will be done really at the end of the project. And some insights are that people really are open for smart charging. So it is user-friendly. It's not that the DSO pushes you or the TSO pushes you or the car manufacturer or the government has to do something. No, it's common sense that you charge your vehicle at night or when it's very, very sunny. But people like to be in control themselves. They want to be, 8 of 10 EV drivers think, in the end, the example is often, I want to go to the hospital in case I need to go. I want to be able to overrule the app, whether they use it or not. And the thing is, smart charging is just a form of, smart charging. When the prices are low, the energy mix is green. Bidirectional charging is giving energy back to the grid. And what we've seen is that people are a bit more skeptical on that, except for the Netherlands. Because in the Netherlands there is already a large use case in the Utrecht area and a little bit in Amsterdam. So there's a lot of positive news in the media. That is our explanation a little bit. And behind the consumer reports, there's also an analysis of the behavior. So the Drivers Association in the Netherlands checked over 100,000 EV drivers. And the Dutch are a bit on the penny. So when prices are low, they start charging, and that is often when there's a lot of grid capacity, so at night or during the day, as you can see here with a green bulb, that is, prices are high, and that's where there's a lot of green energy generation. So that was input given to us by the consumers. The second step we said was analyze all the different stakeholders. As you could see, we had a lot of different value streams in our consortium doing different services, and we wanted to check out the business cases, as Guido said. So everybody at a meeting, everybody's talking with a different viewpoint, and with a lot of webinars, we identified all the different value streams, because the question by the Commission was, what is the business case? But there are multiple different business cases we identified. For example, for the grid operator, the 100,000 consumers showed us well, with a normal tariff scheme price incentive, it works. But in exceptional circumstances, you want to have a safety net and you want to curtail maybe to prevent an overload, because 100,000 electric vehicles, they give you 1 gigawatt on your grid. And well, that is a lot of energy you have to put in a vehicle or extract from it. So this is an example of a totally different business case for a DSO. Skip these a little bit. But these ideas, these different viewpoints gave us, from DSO perspective, a lot of insights for example, regulation the European Commission and Acer is now doing. So you don't really have to wait till the end of the project. Already you can help with, for example, the frequency control regulation. From the value streams, of course, it's not really a business case, but mass scale up is needed, and that's not with wealthy people with an own driveway and an own charging station, but you have to have public chargers available. A majority of people lives in a city, don't have their own garage or driveway. They're dependent on public charging stations, so you need the cities for tendering those. And again, you had some in our consortium cities, Oslo, Göteborg, Utrecht, who could share their best practices. And that's already done, for example, when the city of Budapest did a tender, they used this integrated mobility and planning tool. So it's proactive planning, not waiting for an EV driver when he calls the municipality, hey, I need a charger. No, you can analyze on data, you can predict a little bit where might not you have the charger needed, but maybe your neighbor in that street. We expect there will be EV drivers in near future, in half a year or a year. So you can, as a municipality, be very proactive in installing the chargers. And if you stop purchasing them one by one, but doing large tenders, 1,000, 2,000, maybe even 5,000 at a time, then the business case for municipalities is economies of scale, and the charging stations, the rollout can be much more cheaper and more efficient. But for a tender, you also need some hard and software requirements, and this is also input for the European Commission and the cities. You can help not only with roaming for interoperability or protocols, but also hard and software requirements that not only the consumer can charge at any charging station in Europe, but it's also efficient for charge point manufacturers to know, well, we don't, for specific markets, we don't need specific hardware or other things. So standardization also helps them to reduce cost and make the market bigger. Well, difficult picture, but there's a really architecture behind it. If you're interested in it, you can download all the requirements on our sites, but it gives an idea of all the different, in the previous presentation, also the ISO standardization was mentioned, but we've seen just naming a standard is not good enough, because the standard also improves with adding extra cybersecurity or bidirectional charging. For example, OCPP 2.1 is a protocol facilitating bidirectional charging. But in many tenders, the old protocol, OCPP 1.6, the old-fashioned protocol, is still wanted, and it doesn't facilitate bidirectional charging. So if a municipality asks for this one, the old standard, yeah, you're installing charging stations will last probably for 10 or 15 years. And you know, in that municipality, in that city, yeah, consumers probably can't do bidirectional charging in the coming 10 years because the protocols won't facilitate them. So that's also a recommendation for local municipalities, governments, but also the European government, European Commission. And then the charging station, the infrastructure is installed. We took the approach of solving the chicken and egg problem by first deploying a lot of chargers, later more on that. So you can't have, we can't do a thing because we're waiting on the vehicles. Just install the chargers. That often also takes the tendering, the installation, half a year at least. But then the chargers are there. There are some bidirectional vehicles on the market, but on a small scale. But you can already gain a lot of data from smart charging stations, and you can analyze that. And the universities in the consortium can do fun stuff with that. And then, of course, the deployment. Where are the chargers installed? Well, we have a lot of chargers. We have already the first bidirectional vehicles and a lot of vehicles in the fleets. But it was not only sunny days. This is an example of a hurdle we had to overcome. Sono Motors, really cool startup. And as you can see, the vehicle had all solar panels installed. But unfortunately, they didn't make it. They went bankrupt. So that, you have to shift from car supplier in certain use cases to different ones. And of course, it consumes a lot of energy and, isn't the most positive thing. But luckily, we still have some other German use cases replacing them. The idea was a use case, vehicle to home. So we divided the project in 4 different use cases: vehicle to home, vehicle to business, so at a depot, at an office building. This is an example of the Budapest use case, and also some bumps to overcome. The apartment, the office building didn't want to collaborate in the end with us. So we had to shift to a different location, and of course that is also causing some delay. And then with tight timelines from the Commission, sometimes people get a little bit uncomfortable. But at the moment, we have over 20 chargers installed here. And the good thing is, the best practice, the municipality of Budapest took the system architecture, the hard and software requirements, the best practices of Utrecht, and didn't reinvent the wheel. This is a larger use case in Budapest, 32 chargers, and it's at also a vehicle to business car selling company. So they have a lot of vehicles standing there in stock waiting for a new buyer. And the funny thing is, in Toulouse, there's also such a thing, only this is one of the facilities by Renault, and this is 32 chargers and say 300 vehicles. This is over 3,000 vehicles. Not all are electric, but it gives an idea of where the mass market is heading in 2030, because by that time, the majority will be electrified. And as you can see, the roof is all solar, so you can really make the use case of charge during the day, but also discharge. All the vehicles are waiting for a new buyer, standing idly, and at night they can help the grid, can make a little bit of money for the car salespeople. Another business, an office and residential building in Göteborg. In the end, the city of Göteborg wants to really showcase on a conference next year, the Electric Vehicle Summit, which is organized. They will launch the Polestar by that time and have over 100 bidirectional charging stations. And of course, the factory of Polestar is in Göteborg, so they probably will match it with them. By the way, these are all AC bidirectional vehicles, and that's also done in Oslo. 150 V1G charging stations, so not waiting on the bidirectional vehicles, but first start with smart charging stations. They are matched, not a consortium partner, but a sister company from Hyundai. The Kia EV9 is driving here, not on all 150 V1G charging stations, but in the second half of the project, we want to shift the V1G chargers to V2G chargers. And not only vehicles, but also vehicle to depot, trucks and buses, different use case because, well, they have to be really fully charged the next day to supply supermarkets or drive passengers from one city to the other. And this is done by faster chargers, DC chargers. It's in Eindhoven, in the Netherlands. Over 800 light-duty vehicles, so the buses of a grid operator in the Netherlands. This was actually a surprise for us. We didn't know this. The grid operator stayed in, electrified all their buses, not, well, partly for climate goals, but inner city air quality. So the city of Rotterdam is closing their city for air quality environmental zone in 2025. And to be proactive, all the buses were electrified. But as you can see, the engineers have to do some welding and cable cutting, etc. And they couldn't have a combustion generator anymore for powering the welding equipment. So they have all vehicle to load, not vehicle to grid, because vehicle to grid buses aren't on the market yet. But this provides us a lot of insight, which will be analyzed, provides a lot of data in the second half of the project. And a very, very large fleet, over 800 vehicles, all with their own chargers. And of course, at the office, at the depot, but the engineers sometimes have a night shift and they take the buses at home and they have to charge their in the street on their own driveway. So interesting what the data will bring us. Another car sharing in Oslo, one in Budapest, again with an old market. And this is the Lighthouse project. The data is a bit old because here it says over 650 V2G chargers. Municipality of Utrecht did a public tender in October with 1,700 public chargers. 25 bidirectional Hyundais are already driving, generating data. And this will be one of the launching sites of Renault next year or this year when they come to the market with the Renault 5, the Renault 5. So this is where we stand at the moment. A lot of installations. Some are good, some are a little bit delayed. We didn't wait for the vehicles, but we installed the chargers already generating data. And since we have some of the car manufacturers on board, we know, we've seen at consortium meetings, we've been to the Göteborg factory, we've been to Paris, to the Renault factory. We've seen the prototypes. So yeah, exciting second half of the project when the vehicles will come to the market. Thank you very much.
And thanks a lot, Bart. Well, as you heard from the project, a lot of demonstration and pilots and a lot of results also in the future. So next year, when we will get all the results and maybe I think it will be presented again in one of the next Earthware conferences, this project. Just for your information, okay, now we'll start with the question and answer. If you need to stretch a second, you've been sitting for 1 hour, I'll try to open the door a second to get some fresh air entering. And just to remind you, on the policy point that you were correctly highlighting, so the feedback to policy and how the policy can implement and support, there is also the Sustainable Transfer Forum. For information, maybe you can go and check it. I know that Bart is an active member also of the STF, which is done for the implementation of alternative fuels infrastructure regulation, so to support the interoperability, the standard, the definition of what is needed for the future for the charging infrastructure. It's a good way. You will find also a lot of interesting documents that can support you in research and in all the activities. With this, any specific clarification request now? Then I'll go and open that door to get some fresh air, and I'll leave it to Christof to start with the question and answer session. Thank you.
Okay, thank you, Guido. First of all, again, let's give our presenters a hand. Good. So, are there questions from the audience right away? Yes, Maurizio. Yeah, the microphone is on your way.
Thank you, everybody, for the presentations. Maurizio Maggiore, European Commission. I saw some numbers, but I'm not clear. Also, in view of what the first speaker was talking about, what power levels we are seeing. I mean, I've seen 25, 22, and to me, if they are used at full power, it gives me the idea that this would not be favorable. In the sense that you arrive with the average consumption of 1, 2, 3 days, and in an hour at 7 o'clock at peak time, you finished. So was there, was it just because these are the ones which are available, or is there a logic behind choosing such a high power? Also because I think in the topic we said low power. and 22 or 25 is, as I say, I mean, it also, you mentioned using the battery, and that would cycle the battery more. Mm-hmm. I mean, I see many negative points. So are you using it at different power levels and experimenting at different levels or whatever? And this I would say to all projects, because it was not clear from the project exactly which choices were done.
Yeah, well, in many use cases in the Netherlands, but also Norway, the grid connection is 22 kilowatts, facilitating 2 vehicles. So that's 11 kilowatts per vehicle. It's 3-phase. And for grid operators, a lot of capacity in your eyes. 3-phase is preferred because it's better for the grid. You don't want to have 1-phase charging. But it also gives you much more flexibility. So you can go to the consumer and say, sorry, not at peak time charging. The lady sitting next to you knows a lot about that. But people are willing to do that because they know when there is grid capacity, you are charged within an hour or 2 hours. While with 1-phase, really low, you have to plug in and stay plugged in all night or all day. And, well, if you have congested grids in the Netherlands, well, that doesn't give you any flexibility. We want to use the valley of the night, as we explain it, where you have lots of capacity, or at peak times in summer. At the moment, we have also supply congestion, so there's so much rooftop solar generated, and then you really want to have that 22 kilowatts or 11 kilowatts per charger, so you can take off all the solar energy, which is good for the environment. It's very cheap energy, causing supply congestion. So therefore is the idea, yes, give them the capacity, because that's also giving flexibility. But you want to add?
Yeah, to complement, For example, the INCIT-EV charger, the 25 kilowatt, this is a AC/DC level, then it has two DC-DCs of 12.5, so it's about 11 per vehicle, but this is top power. Of course, you can reduce it maybe to the available PV or maybe to a lower outcome. But it's true that I have to support Bart on that. Usually you have on the afternoon 2 peak hours. So with an 11 kilowatts, you can discharge 25 kilowatt hour in that time. And also maybe between 12 and 2 or 12 and 3, at least in Spain, is when you can use this surplus energy. So it's also good to work between this 7 and 11, which is still the C rate for a 50, 60 kilowatt hour vehicle is still on 0.2 C, which is more or less does not affect the aging of the battery.
This is true today. You have few vehicles, but aren't you risking that when you have many and you have 22, then you are risking of saturating the local grid, for instance?
If I can, regarding the solutions that we are proposing in EV4U project, in the point of view of the DSO, all the tools are agnostic to the power. We can have flexibility with 11, with 22, or with 3.7. It depends a lot in the point where we will connect. If we think that 40% of the persons will charge in houses, not in big cities, but in the other places, and if most of the houses have 6.9 or 10 kilowatts, we'll not install 22, because you never will use this. And we will install something that can be at 22 kilowatts, because this is what we have in the market. But afterwards, we will limit to 7 or something like that. And this is the point. I think that for a building, we can put 22 kilowatts, yes, but why not with 6 plugs? Maybe we'll not use all the flexibility that we have, but if we manage the flexibility at the building level, we don't need to manage this flexibility at DSO level. And this is the point. We should find the balance between some chargers that will have to use these chargers for during all the day, because we are being efficient at building level or at company level, and afterwards we can reserve some flexibility. And the point is how we will provide this flexibility to the DSOs. And to DSOs, we don't need the flexibility during all the day, because the DSO will not use this flexibility. The DSO will use this flexibility 1 hour or 2 hours a day. All the rest of the day, we don't need any flexibility in the system, because we have the system working now. Okay? And this is the point. We should find the balance and between the costs, because of course we'll not install 22 kilowatts in every place. We have the hosting, define the hosting capacity of the grids, and adjust what we need in terms of mobility, what we need in terms of the grid, or what we have in terms of the grid, and how we will plan the expansion of the grid, considering these needs of mobility.
Yeah, and keep in mind the research the consumer organization in the Netherlands has done on real-life data, the 100,000 EV drivers, with a flexible energy tariff. There is a very strong causality between electricity prices and the moment of charging. And yeah, people charge when energy is cheap, and that is often at night when it's windy and there's not much other consumption. And that is good, because then there is a lot of grid capacity, not only in the Netherlands, but anywhere in the world. Or during the day when there's a lot of solar energy, and then it's good that people charge during the day, because then you have a supply peak and the vehicle helps peak shaving. So that is the idea we have. And in roughly 95% of the cases, the market is solving that issue. There will be some cases when the market doesn't work that way, and then you need additional things, and you can do that by public tendering. So the city of Utrecht says you can charge anytime you want, but in certain circumstances the grid operator might interfere So that is an agreement between the grid operator and the CPO, the municipality, that it might curtail, but that is really the last resort. And behind that, of course, that is the current situation. Grid operators anywhere in Europe are still investing in their grids because, well, you do your normal maintenance, and when you maintain the grid, you put in extra cables, build extra distribution transformers, because anywhere in Europe you need more capacity.
Do I see Ian raising his hand?
Thank you. This is Ian Faya from Bosch. Very, very interesting about the 100,000 surveys. And that sort of leads me to my question about if you ask somebody what their priorities are, if you do surveys and things like this, what's the difference between a survey, the results of the survey, and what they actually do? You have a lot of data that you can basically build on that, but I think the same thing is true for all of you. This question is, how do users really behave? And I think
this is data from the energy suppliers. So this is the consumer organization was the first to provide flexible energy tariffs as an energy contract. So it's not only a survey, it's the real data.
But this is exactly, if you compare that to the results of the surveys, what do you see in terms of what are people actually doing compared to what they say on the survey? And Miguel is shaking his head in a positive way. Maybe you can comment on that also, in terms of your knowledge from the surveys?
Sorry, this question of flexibility is really complicated to understand. I think that most of the people are willing to provide this flexibility, but I can give you the example, for example, in the public charging stations in Portugal. When you charge your vehicle, we have two parts of the tariffs. One, you pay for the energy, and another, you pay for the time that you are connected. This means that if you analyze real data, you will not have flexibility, because we are paying for the time. And when you arrive to 100%, you receive a message and will disconnect the card to not pay. And this means that if you still, with regulation that we have, will not have flexibility. But why the regulators do this kind of regulation? Because the growing of the electrical vehicles is much faster than the growing of charging stations. And the point here is we need to find strategy to improve the number of points of charging, not charging stations, that are different things. And we need to improve this smart charging at the local level to reduce the costs of investments. And I think this is the key. When we analyze real data, we need to think in the regulation that we have.
Maybe to complement, in Spain, there is still no charger for home charging that follows dynamic pricing automatically. So it means that the previous day at 8 p.m. you need to check what will be the prices for the next day, and if you are an expert user of the market, you'll say, okay, I will charge today between 3 and 7 in the morning, and then 2 in the morning and 4 in the afternoon. But there is still no automatic, easy to use for the final user charger. And some of the tariffs are 24 hours, same price. So there is a time that the user say, okay, I don't care. I will charge whenever it's plugged. So they are not anymore using smart charging. So this is the main problem that we are facing on the street, on the users. And sometimes they have chargers at home, so they can plug it, and there is no problem with having it plugged for so many hours. But still the incentive is too complex to achieve the final economics of the smart charging.
Afterwards, again, sorry, only to pick this example of the prices, in Portugal we have a time of use, and the users can profit of the lower price during the night. In Denmark, they have a real-time pricing, that is indexed to the markets, and then they can profit of these different prices. But in Greece, we don't have, and this again depends a lot of the regulation. But one point that is, if we think that we'll have 100% or 90% of the vehicles, and if you assume that everyone will be smart, we'll create a new problem, because everyone will charge in the period where the price is lower. And this means that we need to find different strategies. When I mentioned that the services for mobility should be different from services for consumers, this means that we can create, for example, some delays between the points of charging, and giving different tariffs, for example, in vehicles, at public houses and workplaces. If we create different times for the prices, we will avoid some future problems.
Yeah, let's take first the question in the back, and then next is Ian. Yeah. But I'm afraid, like, at least as a private customer, the contracts that I've seen in Germany, they have flexible pricing, like concrete, or like an iron rail or something. So
It's this.
yeah, exactly.
Is it flexible enough?
Exactly.
Yes. In Portugal, we have another particularity, that is, to buy energy, we follow the time of use, but to sell energy to the grid, we follow the market prices. That create a special case.
Thank you. Pedro Gomes, Polis Network. I just want to highlight a good opportunity here that we mentioned. Guido, you mentioned the STF, so how we can connect policy and research and innovation, and also Barte and the discussion here about the tendering. Just as a reminder, at the STF, on the subgroup of public authorities, now we are reviewing the tender recommendations for procurement of charging stations. And as you said, Barte, we have different contexts. So for example, Utrecht is quite advanced, but if you go to Southern and Eastern Europe, and I'm from Portugal, we see there's still a lot of legacy contracts and tenders that do not look at this future-proof technology. So this is a perfect opportunity to make sure that we inform these guidelines and these policy recommendations with the results of these different projects. Fortunately, we have several members of Scale and the other projects in the STF. So we'll try to make sure that one things feed the other, and in the end, AFIR is coming. So policy actually needs, or the research and innovation actually needs to reflect what's the current policy. So let's try to keep that in consideration for the future.
Okay, thank you.
Lucy.
Um,
There's a gentleman there.
no problem. Oh, yeah, Pietro. Yeah.
So this is Pietro Perlo from IFEPS. I have two questions. I remember that some years ago, project like yours tried to evaluate what was the losses during charging. And I remember that there was a big variation between 20 to up to 30 and more %. In few years, what is your analysis? Because as a user, I feel very disturbed. It's paying 100 and I get only 80. No, this is, of course, very disturbing, but also a huge waste of energy. Second question is more provocative. At home, I have 2 bikes. I charge the bikes DC. I also have 2 large EVs. I have 1 charger for the bike, 1 charger for the car. And I also have photovoltaics. So now the question is the same question that I posed to the European Commission 12 years ago, making a presentation to the European Commission. If I have on board the charger, I have extra cost, extra complexity, extra maintenance. No sense from a technological and from a scientific point of view. I was expecting from you that are, say, evaluating many of these aspects, giving a precise indication. We want a DC charger. It's cheaper, less maintenance,
No, sorry,
more efficient.
I have to interfere here.
Please. Yes.
In your vehicle, for the DC, the battery conversion to the electromotor, there already is an inverter. And so it's not adding extra inverters. You should utilize the inverter already in the vehicle better. And for grid operators, it doesn't matter of whether it's DC charging or AC charging. But at the moment, installing DC chargers publicly, so this is mass deployment, curbside charging, DC is big, connected cables, expensive, the vehicles aren't there on the market. Yeah, Volkswagen says they do it, but you can't buy them. Most vehicles, so scaling up the strategy, for me, AC, DC, both is good for the grid, but all chargers publicly tendered are AC at the moment. And well, Tesla announced, Elon Musk announced, bidirectional charging, AC is even cheaper than just normal charging because we figured some smartness out with the already onboard inverter. So that for the second question.
Yes, if I can intervene, just because 12 years that I'm pushing at this, and this analysis is very nice, okay? I am ready to change my mind. I made many calculations, and I never came to this conclusion. I am always convinced that DC charging is cheaper, but the grid operators wanted time ago AC charging, but there was never a technical justification for that. I'm not so sure that when you have DC charging, you have an inverter in the car. This is not. You have a converter. It's slightly different. It's different. And a filter and a converter. If you go really to the side. Oh, but I don't want to there's nothing written in the Bible. What I'm saying is there are several projects. This has to be clarified once forever because it may impact lots of energy consumption and also maintenance in the cars, simplicity in the car. That's the point. So something scientific has to be reported. That's my point.
Well, scientific, maybe also look at the market parties. We got multiple car manufacturers in the consortium. Renault, 2 weeks ago, they did a big item on TF1. Lucy, what is it? You're French? TF1. The national news in France. They're, by the end of this year, they want to produce 500,000 AC bidirectional vehicles, 500,000. So, yeah, I think the European Commission is about open markets, and we're not a communist state. So I don't mind if you want to build DC vehicles like Volkswagen does, do it. If you want to produce AC, do it. If you see a business case in either of them, just let the innovation do it, but don't regulate the technique.
And this is kind of bringing us also to the almost to the end of the session. So maybe there's, Ugo, if you want to give your last comment, then please, go ahead.
Compliment on this, I completely agree with Bart. In any case, in another project that we have, we install more or less 100 DC charging station because we are exploring DC grids. Because in some applications, DC grids can make advantage comparing with AC grids. And if you have DC grids, in fact, we can have DC-DC charging stations, and we will see in the end of the project if we can bring some value comparing with AC. But this is mainly because we have storage in DC, we have loads in DC, we have PV in DC. Shift to DC.
That was easy. That was an easy one.
Yes, in the, if I may, in the project we have very specific applications where the DC can bring advantage comparing with AC. We are talking in data centers, we are talking in ports, we are talking in some kinds of industry that use a lot of robots, and we will also test in grids, but in the buildings, but in the buildings depend a lot of the type of loads that we are considering.
If I might, just one point. I think it's a good discussion, absolutely, and it's interesting. Just to remind what we're doing, it's research innovation, and it's European funded. So, we want to understand what are the challenges of every kind of solution. So we don't need to focus on one. This is, I understand also, Pietro, and I understand Maurizio, because these are valid points in any case. We don't need to find one single solution, but try to see what is possible to do for the future. And Pedro, if I come back to you, the Sustainable Transport Forum is something legislative for sure. Research innovation can give some input for the future, not for what is going on right now. So this is why we need to look a little bit further and try to analyze what could be the challenges in 10 to 20 years' time. Just a reminder, thank you.
Perfect. Okay. So, if I may close the session with a few words. So I really appreciate. Huh?
I think we can.
We have half an hour. Oh my gosh.
Yeah, to 6:30.
Sorry. Yeah. No, I'm done. I'm far too early. Good. Yeah. Okay.
And I see Jan with our.
Yeah. But okay. So then, but
Maybe
then I would
Christof,
also
then
like
I would
not
like
to hold back with one question of mine.
No, maybe an add-on on the DC grids. I work for a grid operator, and we operate public grids. And in Europe, almost in the world, all grids are AC. But behind the meter, as a solar farm, distribution center, computers, that might perfectly be a DC grid, which is also a grid, but from my perspective, it's not a public grid operated by a grid operator. And on the other hand, there are examples of DC cables, for example, the cables between Norway and the Netherlands, that's a DC, but it's facilitating a wind park, generating AC, and then it's made to DC, and then it's on land AC again. So yeah, don't regulate that.
There have been DC along the lines for at least 50 years globally on this planet. But the question is, are we going to do these kind of things on continent level? What kind of investment is this?
Sorry, we have very specific applications where the DC can make sense. And this is the point, as I mentioned, data centers, because all the computers are in DC, and UPS can be in DC, etc. Imports, because we have a new regulation where ships, when are docked, should be connected to the grid. And the ships, some of them are DC, and other ones are 60 Hertz, and pose some problems in this connection. And because of this, DC can make sense. And here, as I mentioned, we have very specific applications where the DC can make sense.
Okay, so question? Ian, wanna go? No, that was. I think you were first. Then it's Ian. Yeah, and then Maurizio.
Thank you. I'm Rafael Huber from ACIN. It's a question to Miguel regarding inductive charging. I was wondering if you made a projection on the cost per kilowatt, for example, kilowatt hour, and compared it to the price or the perspective price of batteries. And based on that, what are the use cases you foresee in the future? Is it only for heavy-duty vehicles, or do you also see it for personal vehicles? What is the analysis on the cost side, basically?
Did you ask for the cost of the infrastructure or for the cost of the recharging itself?
Well, in the end of the recharging.
Recharge.
So the cost of the electricity and whether it will be interesting enough for people to reduce the capacity of the battery compared to the battery price. More or less, I don't need exact numbers, but what is your view on that?
Okay, quite interesting question. This has been always a point for inductive charging, so we can reduce the battery size in case that we have an inductive charging infrastructure enough to allow all the vehicles charging, driving while charging. To be fair, we are reaching some numbers that are comparable to the cost of the infrastructure itself. So we can reach lower cost than the road itself, so it's not that bad, the cost of investment. But it's true that at this point, where this is feasible is for captive fleets, including taxis that on a city level, they are working always on the same place, maybe for material handling equipment that are always running 24 times per hour, maybe for some buses at the stops, for some semi-dynamic charging. So still, the full implementation of inductive charging on roads is still on discussion. So maybe in 10 years time frame we'll have that answer. What I can offer to you some prices, maybe is for the static charging. More or less the cost will be maybe, the cost of the infrastructure will be maybe 50% higher than the conductive one. So in case of the intensity of the use, it could be a little bit higher, but not that much higher. But this still depends on the application and the use, the time of use of the charger. If it is empty all the day, as is right now happening on some of the chargers, then the price needs to be higher. If you have a large rotation, because this is a heavily used infrastructure, then the kilowatt hour will be, of course, reduced, and it will be more reliant on the energy prices rather than on the infrastructure price.
And that comparison relies on electric road systems now, yeah? So whether conductive or inductive, okay, yeah. So you, with your charging station that you showed, there was one charger that could do a V2G connection, 25 kilowatts, up to 200 kilowatts. Does V2G with 200 kilowatts make sense?
No, it doesn't make sense, of course. But it's true that this was an escalation of the 25 kilowatt system. So all the power electronics are V2G ready. Even for the inductive demonstrators, we are able to perform V2G even using a contactless system. So it is prepared, but of course for 200 kilowatts, I mean, the vehicle already has its limits. For example, for the Nissan vehicle in which we have been discharging, it's limited sometimes, depending on the state of charge, to 6 kilowatts. So it doesn't matter that you have a 25 kilowatts, that the manufacturer will have a limit on the power depending on the state of charge.
And for the dynamic ERS systems, what was the gap width between the antennas?
We have maintained the exact height that a standard vehicle has. So we have modified the suspension a little bit. The coil is like 30 millimeters, so we have increased the height 30 millimeters. So we have maintained existing gap of a commercial vehicle. So just maintaining the original place. So it's about 30 centimeters of gap, more or less.
Did you observe any disturbances in the radio system or around?
We are indeed the Paris demonstrator. It is on public street, and the City Council of Paris has been they wanted to have the confirmation that we are meeting the highest standards. To be fair, there is still no process to certificate this, but we have made on lab test, on the one that you have seen on the videos, we have measured the electromagnetic emissions, and outside the vehicle they are okay, and inside the vehicle it is shielded behind the vehicle. There is aluminum shield, so inside the vehicle there is no electromagnetic emissions. So we have measured that at a safe distance of the vehicle, so it will be not 10 centimeters, but a safe distance of the vehicle, the electromagnetic emissions are in line with the requirements.
Okay, thank you. Maurizio, your question?
How many vehicles do you will use in Paris?
We have one Renault Zoe, one DS3, and one Renault Master. So it will be 3 vehicles. The light vehicles will have only 1 coil per vehicle, and the Renault Master, as it's longer, we are able to include 3 coils, so it's able to charge up to 90 kilowatts. In the case of the urban one, they activate 3 coils at the same time. In the case of the long one, the 3 are activated with only 1 coil in the ground. So different techniques for the same interoperability.
Yeah, I would like to look back a little bit also with the question of Piero and my previous one. One of the few cars I know that has the inverter used as is very poor efficiency. And a lot of cars which are on the market today at lower than peak power is the same. So what you say that you want the flexibility and you start with 22, it means that if you use the flexibility, you are throwing in the bin 20-30% of the energy, not to mention to weigh. So the general message I say to the projects is that the call wanted exactly this kind of comparisons. A total system approach, not the TSO, not the DSO, not the customer. What is the benefit for everybody? Because when we will have millions of cars, even 10% of losses accumulated across the whole thing, not to mention 20 or 30% as we see. I like to see reality, not theory. And reality is huge losses. I see in my car.
That's not true.
Well,
maybe I can respond. It's absolutely true by the first generation of bidirectional vehicles in the past. We have a test lab in Arnhem where we test exactly this. Not only smart charging protocol development, but also power quality, because that affects the grid, harmonics, losses. And for the first generation of electric vehicles, such as battery degradation, first generation, the old Nissan Leafs, now you can maybe drive 60 kilometers with it. But this is also the car manufacturers had innovation on the batteries, but also on the electrical components, making more quality. And we recently had a prototype of an electric vehicle who was even more efficient discharging than charging, because, well, car manufacturers just assembling components, and they also learn. And every now and 2 or 3 years, you're from Bosch, your products of 5 or 10 years ago had less efficiency than the products now, and you're a tier 1 supplier. So true, but also actually test and ask that in new horizon programs, because it's just this, battery degradation is also in one of the products, maybe not on this table. Do research on it, because consumers hear rumors, and universities have to explain, and our test lab has to show, yeah, true, but not anymore.
We need numbers. At the moment, I haven't seen, for instance, a reply on how much degradation with which cycles and which power. And again, if we think you're using 22 kilowatts rather than a lower number, it might be bigger. I don't know, but I would like to have the numbers. I mean, the point is the topics were asking exactly these questions, including, let's say, guidance for future legislation. I heard the question, we should comply with current legislation. No, because if it design now something complying with current legislation, and we want something for the moment where we'll have millions of vehicles, maybe might be different. This is.
But this is also a policy recommendation. In America, they have this, I'm not sure if it's DOE, Department of Energy, or California Energy Commission, but one of the two has Energy Star, and it is efficiency norm that you can't have more than, I think, 2 or 3% energy losses in the whole value chain. And then companies like Bosch or Siemens or Continental or whoever say to the car manufacturers, okay, you have to comply to this law if you want to export your vehicles to America, and then the European Commission can also do this with road application. That's a thing ELA really would like to say, don't test on crash tests and etc. and tailpipe emissions, but also test on the charging behavior and the harmonics, because that is causing the losses. And then, yeah, it is better for European business because our producers are known for high quality equipment, and the cheap equipment comes from China, and that is causing the losses.
Only
Take the microphone.
Sorry, it's, we have 10 minutes. I think if there is a...
We have online people as well.
Do you see any?
Yes.
The GVI project and Green and CAP is testing this, because you see from the WLTP how much difference there is, and the losses are still there. They tested, they are starting publishing recently, and one of the best is the Chinese one.
Yes, but only to mention that we have a charging station manufacturer in consortium that in 10 years have 5 different charging stations, several updates improving the quality. One of the things that is regarding the harmonics and the reactive power is something that we should really look, because are really impacting the efficiency of the charging stations and vehicles. Another point that is, we have some services that we cannot provide with vehicles. For example, when we define strategies to improve the self-consumption, sometimes we have very low power consumption, and if we adjust our power production, and if we adjust the charging the vehicle to 100 watts or 200 watts or 300 watts, in this case losses will be very high. And what we should do is define some limits and know exactly the curve of losses of the charging stations and vehicles to set up the algorithms accordingly.
So, yes, Guido has a question.
I have a question as well for you, well, for all of you. Just because we were really technical, but I would like to go back a second on the user friendliness of the solution and what we're trying to do. And also to understand, because I saw a couple of slides on the numbers of concerns and fears by the customers, the users. We do the technologies, but then will it be used? So I'm asking, and I saw, for example, Bart, one of your slides saying 8 out of 10 EV drivers have some concerns on the vehicle to X. But the vehicle to X, did you investigate if it's vehicle to G, vehicle to house? Do you find any way in which we can get nearer to the customer and show them this is a good solution? It's for all of you, a question.
Yeah.
Thank you.
Yeah. Like vehicle to house could be kind of a Trojan horse to get the people on board, yeah?
I guess people might accept it maybe more easily. Did you investigate this as well? Or will you do it in the future of the project? Thanks.
Yeah, there will be a third consumer review, but what I highlighted, for many people this is new, and people think of battery degradation and energy losses because my neighbor said, and I know a friend of a friend. But also we trust Renault is investing big time, Kia is investing big time with all their marketing, and it's up to them to convince their consumers and not the government this is a good thing to do. They want to sell these vehicles, they want to sell an energy subscription, and this is already happening in the Netherlands, and therefore I highlighted this is a funny thing. 8 out of 10 is a little bit reluctant, except for the Netherlands, because we see so much positive news about,
Maybe more direct, and then I leave it also to the others. Is vehicle to house a Trojan horse to help enter into the house and support even a more user-friendly use of this kind of solutions? I don't know, I'm thinking,
As we are approaching to the end of INCIT-EV, one of the results that we are going to provide is the full efficiency of a charge and discharge cycle. This is not usually offered, and this is why I believe that the people is navigating into the dark, because they don't know what are the real efficiency of the charger on one way. I'm not asking on two ways. So we are going to provide this on our chargers, on the test, to be comparable also with all the solutions that we are developing in the project. And also this will provide the inputs for the OPEX information for the business analysis of all the use cases. So we'll know if we use 3 cents per kilowatt hour for charging, what will be the cost of discharging this in a later stage in order to have the information. I have specifically asked to all of the use cases to have these easily comparable KPIs for efficiency. So we'll have this real data, scientific data, at least for all the pilots with different technologies to be comparable with this efficiency. But it's true what you have said, that working at to achieving the 97% maximum efficiency, you need to work at 90% of the full load. If you work at 1 kilowatt out of 10, it can be lower to 85, or if you make it twice, yeah, you just need to multiply.
If I may add, probably we all remember 10 years ago when smartphones were on the market. We did not jump for a smartphone. We were so happy with our Nokias, and we said, no, I will always have this small Nokia which lasts a week or 2 weeks with single charge. And similar here, we need to give time to people. When we were writing the project 2 years ago, V2X was not known acronym. Now people are talking in the street. The car manufacturers who are all against it publicly are now saying they're coming in this year or so on. So it's a big shift and it takes time. Just a conclusion as the last sentence. We should be careful that we don't mix research and the commercial part in the same sentence. We need to give opportunity to researchers, to students, to everyone to experiment. This is the only way. And then, of course, the document all the ideas properly, and then industry can use them afterwards later on and add them when other conditions are met, and maybe not at this moment.
Okay. If I can add something, one of the important things regarding the V2X is that the car manufacturers should provide information what are the services that we can provide without continuing the guarantees that we have about the batteries. This is one important point. Another thing is the users want to be in control. And for example, in strategies that we are developing for houses or buildings, we have different strategies where in one point the vehicle can discharge more energy and have more profits, but have more risks, and another ones that are less aggressive and can make less money participating in this vehicle to grid. But in any moment, the user can decide to not provide these services. And this feeling of control is something that we should provide to the users. The third thing that we should provide is a clear information about the monetary benefits, the economic benefits that they will have. And this is really important to change this paradigm. In any case, it's something that we should understand the values of the services, what are the degradation that we'll have, and provide this information. We should be clear in the message that we'll provide to the users.
Thank you. One last question from my side, and then the very last question from Ian. So you were talking about the different
Really short, eh? You
Yeah.
We have 3 minutes. We
Yes,
can do that.
you talked about the different communication standards. So which measures are foreseen to enable an upgradability of the charging infrastructure in terms of future standards?
Well, the Commission is a bit reluctant on mandating standards. I work a lot on OCPP, And there was a strong belief that there should be a different IEC standard. Well, that battle is won by the Open Charging Alliance. So OCPP is de facto the global standard. It's mandated in America, in Japan, in Korea. It's used in India. It's a European protocol, but not good enough for Europe. So that was a little bit strange. But on the other hand, that is also a competition. Let the market choose which standard they want, because traditional standards are developed, IEC standards are electrical engineering standards, ISO often a little bit automotive. And one of the successes of OCPP is that it is a cross-sector collaboration where we have car manufacturers working with grid operators and energy suppliers, and that is not in traditional standardization boards. And that itself, development of new types of standard is innovation also. And maybe not mandating standards too early was also a luck in disguise, because that really got the attention of the market, not laying back, but really doing it themselves.
Okay, thank you. Ian, very quick. Take the microphone and then...
My 100 questions. To the electric road system, a question regarding chicken and egg. How much road do we have to build to have out there in terms of captured capital? Have you done the business model, the business case for that? Because you have to have X thousands of kilometers of road before people will actually buy the cars that will run the road.
Yeah, at this point I cannot answer that. Just to say that we will probably see it on captive fleets. But at this point, there is not enough standards, so anyone cannot invest at this point on this technology. I will say also a topic for automotive industry to pay for also the standards on because I mean it doesn't make sense if any company develops a standard on a frequency if it will be not compatible with the secondary that an automotive player will decide to be installed. So until we don't have this standardization on the secondaries to be used on the vehicle, we cannot even think about these questions of full deployment.
Well, if I can just a short comment on the standardization. Of course, European Commission is not pushing because it hopefully coming from the INCIT to agree. If nobody's agreeing, then somebody will impose it.
Okay, and then with this, let me just point out that tomorrow at 9 o'clock, there will be a new set of sessions around here. In the Archimedes, we talk about electric vehicles again, and where is the plan? Yep. So there will be the next generation electrified vehicles for urban and suburban use. No, that's yeah.
It's on the slide. It's also on the
Okay,
slide.
there we go. It's an Einstein. Here, in this room, we will be talking about CCAM and connectivity. And on the other end of the, in the other wing of the building, fuel cells and applications will be discussed. So thank you for joining us here.
Last thing, I remind you also there is a small exposition. If you have the time, just even tomorrow, have the time between one session and the other to come and pass by and see the stand. Maybe you find some useful information.
Yes, exactly. Okay, thank you. Have a good night.